Hello students, we have come to the end of chapter 1 and let's just cover just one more point before ending this introductory chapter. So far we have been drawing structures um, with a line between the atoms as represented here, right? So this is an example of a compound called as 2-methylbutane, and this is one way of drawing your structure where every carbon atom is shown and every hydrogen atom is shown, and the bonds between the carbon and hydrogen are also shown. Okay. However, there have been several shorthand methods that have been developed to write structures because it's very cumbersome to write such a structure, especially when we are talking about larger molecules. So there is a form of drawing structures which is called as the condensed structure. Here the carbon-hydrogen bond is not shown. Um, um, Instead, it is understood that there is a bond between carbon and hydrogen, each of the hydrogens here. Okay, so if a carbon has 3 hydrogen atoms bonded to it, like this one, then it is shown as a CH3. If it has got 2 hydrogen atoms bonded to it, then it is shown as a CH2, and so on. Okay, so there are two different ways of writing condensed structures. One is where you can show the branching separately, or you can also write it down in such a way that the CH3s here, which are connected to this carbon atom, the CH3, this CH3, and this CH3, which are connected to this carbon atom, is then written in parentheses with it twice to it. Okay. Even simpler than writing the condensed structures, there is another form of drawing structures which is actually called as the skeletal structure. There are three main rules that you have to follow in order to write the skeletal structures. The first rule is that the carbon atoms are not shown. Instead, a carbon atom is assumed to be at each intersection of two bonds and at the end of each line. Okay. Hydrogen atoms are also not shown because carbon atom has always a valency of 4, and we will mentally supply the correct number of hydrogen atoms to each of the carbon atom. And the third rule is that any other atom other than carbon and hydrogen are always to be shown. Okay, so let's look at the examples that are shown in this section, table 1.3 from your textbook, where the molecular formula is given C5H8, a structure where each bond between the carbons and the hydrogens are shown. That's one way of drawing the structures. But then the skeletal structure of this compound will be drawn in this way, where it is assumed that each intersection here has a carbon atom. So we have 1, 2, 3, 4, and 5. Okay, so the end of each line is a carbon atom, and then you mentally supply the number of hydrogen atoms to fulfill the valency of carbon. So here the carbon atom here will have 3 hydrogen atoms because it has got only one bond, so it needs four to complete its octet, right? Here this carbon atom already has 2 bonds, so it will need 2 more hydrogens, which are here. This carbon atom has 3 bonds, so it needs only 1 hydrogen atom, so this is the one. And then this carbon atom needs only 2 more hydrogen atoms because it already has 2 bonds here. In that way, you can look at the other examples too. Here we have methyl cyclohexane. C7H14 is the molecular formula. This is the one way of writing the structure. A more easy way would be a skeletal structure here, which shows again 7 carbon atoms. So 1, 2, 3, 4, 5, 6, and 7 here. And then the rest are all the hydrogens. The last example here is with a heteroatom or a different atom other than carbon, which is oxygen here. And the way you will write this structure is skeletal structure would be in this manner. Okay. One more comment regarding drawing skeletal structures is that although groupings such as CH3, OH, and NH2 are usually written with the carbon, oxygen, and nitrogen atom first, You can also write it inverted, like in this case it is inverted and written, which tells us the correct order of writing, because this tells us that the oxygen atom is bonded to the carbon atom. Same thing with here. Here we can invert the order and write this as NH2, so that it's clearly understood that it's the nitrogen that is connected to the carbon. Okay. Same thing here. You can invert the order, writing carbon connected to the carbon atom here. Okay, let's solve this example problem from your textbook. It's a worked example, but we can work through it. Carbon, this is a structure of carbon, and it is a compound that is responsible for the order of spearmint. So the question is asking you how many hydrogens are bonded to each carbon and give the molecular formula of carbon. Okay, so let's try to draw this in a larger structure. So I have this here. There is a double bond here, double bond here, and then this is a single bond. Okay, let's draw this out more clearly. Okay, so that's a double bond, and then here I have a double bond and a single bond. Okay? So if you let's use a different color and highlight all the carbon atoms first. So we have a carbon here, so that's 1, 2, 3, 4, 5, 6, 7, then 8, 9. Did I miss anything? And then one here, right? So C10. So we have 10 carbon atoms. How many hydrogen atoms? Remember that we have to mentally supply the number of hydrogen atoms to fulfill the valency of carbon. So now this carbon, how many hydrogens you will put? You will put 3 here, because the carbon has only one bond here. Okay? This carbon here will have 2. This carbon here will have one more. Carbon here will have 2. Okay, because this carbon has already 2 bonds, right? So it needs 2 more. This carbon has 1 and 2 and 3 bonds, so it just needs 1 more. So that's how you have to fulfill the valency of carbons with hydrogen atoms. Now continuing here, now you think you must have understood that here it will have 2, right? Here how many? Just 1, because already 3 bonds are there. Here none, right? Because see, we have already 1, 2, 3, and 4 bonds, right? So this carbon atom here will have no more hydrogens. What about this one? Same thing, no more hydrogens. Okay. What about this? Now here it will have 3 more. Okay. So let's count the number of hydrogen atoms. We can start from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have 14 hydrogen atoms. And then how many oxygens? Just 1. That also needs to be added. So this is my molecular formula, and there are 14 hydrogen atoms that are bonded to the different carbon atoms in this molecule. Okay, so let's do another problem here. Problem number 1.42 from your textbook. It's asking you to convert the following structures into skeletal drawings. Remember that carbon atoms and hydrogen atoms on the carbon need not be shown, but any other atom like the nitrogen and the hydrogen bonded to the nitrogen needs to be shown. Okay, so let's try to do that. The skeletal drawing for this molecule would look like this. Double bonds need to be drawn. This double bond also, and then here you have to show the hydrogen atom that is attached to it. Okay. Here the next one, we have a 1,3-pentadiene, double bonds, 5 carbon atoms. Here the last one is 1,2-dichlorocyclopentane, so a 5-membered ring, and 2 chlorine atoms. Okay, let me redraw this one more time more cleanly. So a 5 2 chlorine atoms. So chlorine here, chlorine here. You have a good practice on those, and we have one more here. It's asking you to give the molecular formula of this estrone, a hormone. So what you need to do is count the number of carbons and the number of hydrogens that are attached, and also the number of oxygens. Okay, so let's draw out the hydrogens, because you can count the carbons, or maybe we can highlight the carbons with red. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so I have 18 carbon atoms. Now let's draw the hydrogen atoms on each. There will be one here, one hydrogen here, one hydrogen here, no hydrogens of these, 2 on this one, 2 on this one, 1 on this one, 2 here, 1 here, 2 here. This one has no hydrogens, this one also has no hydrogen. Here there are 2, here there are 2, and then this one has 1 hydrogen atom. Okay, and then don't forget this carbon atom. Okay, so we have 3 here, right? So that completes the total number of hydrogen atoms. Let's count and see. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Hydrogen is 22, and oxygen, how many? 2 of them. Okay, so let's make sure our answer is correct here. Yes, so we have C18, H22, O2. Okay, so that concludes chapter 1. Make sure you are doing some more textbook end of the chapter problems from the textbook. It's really important that you complete practice problems, otherwise there will not be a good understanding regarding the topics. Okay, so we'll do the next chapter in the next week. Let me know if you have any questions. Reach out to me through emails. Okay, thank you.